Hi guys, Mr. Kane here.
Hi guys, Mrs. Goswish.
Yeah, let's just go. It's molecular formula.
I got nothing.
Yeah, I got nothing.
I call this one MF for short. Remember,
Yep.
I called the other one empirical formula EF for short. Now this is MF.
All right, so a molecular formula by definition is the actual number of atoms in a compound. It turns out that the molecular formula, the MF, is a multiple of the EF, the empirical formula.
So is the empirical formula kind of like the shortcut formula, and then this one is the real formula?
This one's the real formula, yeah. Yeah, it turns out that based on the science at the time, Dalton's time, they could only really get empirical formulas. They needed more sophisticated equipment to figure out the moleculars.
Okay.
Okay, so basically CH3 we know is an empirical formula.
Correct.
So a molecular formula is a multiple of this.
But I could state a couple of different molecular formulas for that, Mr. Kane. I mean,
Like what?
well, I could do C2H6, C3H9, C4H12. I see a couple of different multiples.
There's
floating around in there.
several options, and matter of fact, you missed one. You missed CH3.
Oh, because the empirical could be actually the molecular.
Right, the empirical and the molecular might actually be the same formula. Or it could be, like you said, C2H6 or C3H9 or C4H12. And matter of fact, there's an infinite number of possibilities here.
Okay, so how do you work the molecular formula?
That's exactly what we're going to talk about today. I'm glad you asked.
Okay.
All right. So, to use we use the empirical formula to determine the molecular formula.
Okay.
And there are steps.
Oh, more steps.
Yeah, there's no poem this time. So first you find the empirical formula.
Okay.
Find the empirical formula is the poem. Percent to mass, mass to mole, divide by smallest, multiply to whole.
Percent to mass, mass to whole. No.
We've recited this in class 1,000 times, Mrs. G.
Gosh, and I still can't get it. Percent to mass, mass to moles, divide by smallest, multiply to whole. I got it. Technically speaking, then, we would have to do the previous video steps.
Right.
Okay, to get to this point.
To get to this point, to get number one, it's all 4 steps.
Okay.
Okay. Then find the empirical formula mass. So that's exactly like finding the molar mass. It's just that it's the empirical formula's mass.
Okay, so
it's
you
not
just add them all up.
Right, add them all up.
Okay.
Then you divide the molecular mass by the empirical mass. So you're trying to find a ratio.
Okay, you're trying to find the multiple.
Right, and like it says here, you're going to be given the molecular mass. Okay, because we need sophisticated equipment to come up with that.
Yeah, it's got to be in the problem, doesn't it?
And then you multiply each of the subscripts by the answer from step 3.
So you multiply the subscripts you got for the empirical by the number you got in number 3 to find the multiple of the molecular, and then you get the molecular mass.
Right.
Oh, not mass, I beg your pardon. Then you get the molecular formula.
Right.
The molecular formula is a multiple of the empirical.
Right.
That's very easy.
So the whole reason why you do step number 3 is you're trying to compare how heavy the actual molecule is to the empirical formula.
Well, it's the ratio.
So if the molecular mass is twice as heavy as the empirical mass, you multiply everything by 2.
Then the molecular formula is twice the empirical formula.
Right. If the molecular mass winds up being 3 times that of the empirical mass.
And the molecular formula is 3 times the empirical.
Exactly. That's logical, right?
Yeah, this is a snap.
Science is logic. All right. The empirical formula for ethylene. This is the first way to do it. The empirical formula for ethylene is CH2. Find the molecular formula if the molecular mass is 28.1 grams per mole.
Okay, so they already did all the work for us. They're actually giving us the EF in the problem.
Yeah. The empirical formula has already been done for you. So
That's
they
nice.
they did percent to mass, mass to mole, divide by smallest, multiply till whole. So
you know that poem a little too well, Mr. Kane.
I've said it for years and years and years.
All right.
All right, so find the molecular formula if the molecular mass is 28.1 grams per mole. So they gave us the molecular mass.
Okay.
Where we need to start is we need to start at step 2. Step 2 said find the empirical mass.
All right, so we have the empirical formula. We need the empirical mass. There's 1 carbon and 2 hydrogens.
I can do this by hand. So we're talking about 14.03 grams for the empirical formula. Right?
Empirical formula is mass.
Mass.
Throw an M in there, so yeah, thank you.
Okay. Well, there was a grams there.
Okay.
All right, so when we do this, we want to make a ratio out of this. We want to compare the molecular formula's mass to the empirical formula's mass,
which will give you a value of 2.
which should give me a whole number, which it turns out 28.1 divided by 14.03 is close enough to 2 to call 2. The grams and grams cancel. So what this is saying is that it's 2 times more massive.
Okay, so the molecular formula is twice the empirical.
Right.
Okay.
So, and that's why it says always a whole number here. This is always a whole number.
Mm-hmm.
Okay. What that means is that CH2, we have to multiply everything by 2. That's the empirical formula.
Okay.
The molecular formula, after I multiply things by 2, is going to be C2H4.
H4.
And this is my molecular formula.
Which is the actual formula of the compound.
Right, that's the actual formula, the real formula.
All right, now, Mr. Kane, for the ratio, I like to refer to it as the me ratio because it's the molecular mass over the empirical mass. So I kind of call it the me ratio.
The me ratio, molecular over
Right.
empirical.
And if that doesn't work, the big number's on top.
Yeah, the big number is always on top because
Yeah.
the empirical is always smaller than the molecular.
Yeah,
The empirical is the reduced form
correct.
by definition.
Ooh, okay.
All right. So if you know your definitions, logic should help you. Science is logic.
I thought science was repetitious.
It's repetitiously logical.
Okay.
It's logically repetitious.
All right, so here's example number 2. We have an anti-cancer medicine, which is carbon, hydrogen, and nitrogen percentages given.
All right.
And again, all molecular, all on the right-hand side, so a molecular compound, just like the previous example. The experimental molar mass, hey, wait a minute, why is it called molar mass now instead of molecular? That's the same thing, though, isn't it?
Molar mass and molecular mass are the same concept.
Okay, good.
It's just two different words for the same thing.
That kind of threw me.
Because the molar mass is the molecular mass.
Yeah. All right, now we were not given the empirical formula in this example like the previous one, so we have to go back and do those steps, yeah?
Right, so I got to do percent to mass, mass to mole, divide by smallest, multiply to whole, which you can see that I've already got started on while you were blabbing on, Mrs. G.
Oh, sorry, Mr. Kane.
Yeah, that's okay. You gave me time to work here. I'm getting going here. Hydrogen is 1.01 and
All right, so let's see. From mass to moles, the carbon is 4.28 moles.
4 sig figs.
4.280 moles.
Okay. 3 sig figs.
The hydrogen is going to be 8.54 moles. And the nitrogen's going to be 2.853 moles.
Okay. So, step 1 done, step 2 done, step 3, divide by the smallest.
So that's the 2.853 is the smallest of the bunch, and you divide them all by that.
All right, Mrs. G, last time I didn't give you the chance. 2.853 divided by 2.853?
1.
All right, there we go.
I can do it in my head.
How about carbon? 4.20 divided by 2.8?
Divided by that will give me 1.50. Oh, I'm going to be doing step number 4.
Yeah, and I'm just going to write down 1.5 because I know these are going to be
Yeah, you're going to
easy
whole numbers anyway. And then the hydrogen is 2.993340343. I'm going to say 3.
I'm saying 3 too. That
Yep.
seems logical. All right, so step number 4 is multiply till wholes. So it looks like 2 is what I'm going to need here. So I got to multiply them all by 2. And what I'm getting for an empirical formula is, let's see, I'm getting 3 here, 6 here, and 2 here.
Nice whole
so
numbers.
The empirical formula, EF, is going to be C3H6N2. I hear you punching buttons there, Mrs. G.
Yeah, how come, Mr. K? What do you think I'm up to here?
I'm thinking you're finding the empirical formula's mass for me.
You are so right, Mr. Kane. The empirical formula mass, Mr. Kane, is 70.11.
All right, 70.11 grams for the empirical formula mass. Now, The me ratio, as you call it,
Right.
should be
The 210, which is given in the problem.
210 divided by 70.11.
And I get a 2.99529.
Oh, that sounds like 3.
That sounds like 3.
So what this tells me is the molecular formula is 3 times heavier than the empirical.
Okay.
So I'm thinking that for a final answer for the molecular formula, I'm going to write it up here since there's room, I'm going to go 3 times heavier. So C9,
Uh-huh.
H18,
Uh-huh.
N6.
All right.
Each of those is 3 times more than the empirical
So
formula.
that's the actual formula, and the other one is the shortcut formula.
So I'm going to write MF, C9, H18, N6.
Okay. Ooh, we were right. Ooh, a homework assignment, Mr.
Ooh,
Kane.
nice homework assignment
On a
here.
clean sheet of paper, titled, with your name, show your work.
Okay, so same instructions as always, right?
Right.
Science is repetitious.
Yeah,
So
so
are we.
homework mold 5, make sure you title your paper, make sure your name's on it, make sure your work is shown, and turn it in.
Yep, press pause. All right.
Goodbye.